Hi everybody. How's it going? That's how I'm going. A headache today. I think it's the weather. It's like rain thing that it's doing here.
Yeah.
It's gonna snow really bad. It's supposed to snow badly tonight.
Oh, really? So you say.
It'd be a shame if it snowed so badly that we couldn't come to school. It'd be such a shame.
Alright, so to this point we've assigned like, it was like 1 through 14 or something, 15, something like that. Are there questions on homework to this point? Alright, fair enough. Today, we're going to be looking at side, 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 and side angle side cases. So, in the side angle side and side 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 cases, we're going to be using the law of cosines. Again, to do the law, or to do a side, 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 or side angle side situation, we're going to be using the law of cosines. Again, there's kind of 3 different versions depending on kind of what you're given. We'll just kind of talk through a couple examples here of doing this using the law of cosines and solving side angle side and side angle and side 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 triangles, and then we're going to go and marry, like this procedure onto the flow chart, and we'll put the side angle flow chart, attach that to it, like make a big complete any problem we've done so far flow chart out of like all these 3 disparate pieces, because we had the angle side angle angle side day, we had the side angle day, now we're having the side and side angle side day. I'm going to marry this all together to one big flow chart to kind of take care of a description of what to do. Sound good? All right. Let's party. And by party, I mean do math. So let's say we have a triangle with angle A is 34 degrees, side B is 14, and side C is 17. I want to solve that triangle. First step would be to draw and label a picture so we can decide, is this the side angle side or side angle? Because I have 2 sides of an angle, it's not entirely clear which one of those 2 situations I'm going to land in. I mean, it probably is based on the name of the section we're doing, but like, suspend your disbelief and pretend like you didn't know, we don't know that this is a, coming from a specific lesson. So I've drawn and labeled my triangle. Remember, how do I have to label my side lengths? Opposite the angle, good. I'm going to go ahead and add in my givens. Based on our picture, what situation are we landing in? Side angle side, right? Because I notice the 2 sides make the given angle. That's what side angle side should look like. So we're going to be using law of cosines here. Based on the given information that we have, yes, Alex?
We're using a lot of cosines because they're contributed into it.
Based on the given information, there's only one thing we could possibly find here to start. It's gonna be side A, yeah. So if I apply the law of cosines, I'm gonna say that A squared is equal to B squared plus C squared minus 2BC times cosine angle A. Just going ahead and substitute the numbers in. Let's pound that through our calculator since we just have numbers here on one side, right? Like, am I gonna type this in more than one step? No, man, like one big old line on my calculator is all I'm gonna do. I don't have the one I wanted. Where are you? Shoo! Thanks. Oh, that was a big one, guys. Next door hurt me.
Yeah. It's the weather, man.
Yeah. All right, so we had 14 squared plus 17 squared minus 2 times 14 times 17 times cosine 34. Very good. So there's my value for A squared. Remember the formula is it's A squared, whatever that was, 0.4-ish. So if I want just A, what do I have to do? Yeah, square root both sides. It's not you. Yeah, this is that's good. So about 9.51. We'll do this before my next round of sneezing disturbs next door also. Now we have enough information to solve for either angle B or angle C, right? And in all the problems we've done up to this point, the order didn't matter, correct? Do whatever you want, it's fine. Here it does. The reason the order is going to matter is because you don't want to accidentally stumble into an ambiguous case where you're using two sides in an angle. That would be bad. Nobody wants to deal with that. To avoid the possibility of stumbling into this, like into an ambiguous case when you're doing one of these side, or side angle, side problems, we're going to follow a very specific order in how we're solving the remaining parts. Or solving the angles, I guess, really is the part that we have to be careful about. As long as you follow the order that I'm prescribing, you can ignore any possibility of stumbling into an ambiguous case where you have like a weird side angle situation where it's like, oops, I found the angle from the wrong triangle. Ugh. Okay? So, when doing a side angle side, you find the smaller of the two angles first. If we go back and we look at our triangle, which angle is going to be the smaller of the two? Angle B or angle C? Angle B, good. Why, Rico? Good. Yeah, because angles and sides are proportional. Since side B is shorter than side C, you know, angle B is gonna be smaller than angle C. Everybody feel good there? So we need to find angle B next. Now to do that, we can just do a law of sines. Since this is like a side angle situation. So I can say sine of angle A over side A equals sine of angle B over side B. Yes, Alex.
So we did, last class we did, angling the side, right? And then
You did side angle.
side angle.
Yeah.
So we didn't have to use, we just could go straight into the law of sines without having to do the.
For the side angle, you have to do a bunch of analysis
Yeah.
to start to decide whether you want at 0, 1, or 2 triangles possible. But after that, you solve using the law of sines. And the order is kind of prescriptive, right? You have to find the missing angle next. The only thing you can find is the angle opposite the other side that's given. And then you have to find the third angle, just doing 180 minus the other two. And then you have to find the last side as last. Like there's no other order you can do it in because you don't have enough information to go in a different order. Here you do, right? There's no reason you couldn't have done angle C before angle B. You have all the information you need to do either one of them. But to avoid accidentally stumbling into a 2 triangle situation, we're going to go in this specific order to avoid that possibility occurring. Is okay? Is that?
Yes.
Okay. All right. We have our proportion. Cross multiply. Everybody's good? Divide by 9.51. And then how do I get rid of that sine out front of angle B? Sine inverse. Everybody's okay? So 14 times, sine inverse of 14 times sine 34 divided by our previous answer. So 55.44. Sounds good to me. Doing that all in a different color. Silly thing to remind you of to be careful about. Make sure you're writing your answers in the right places, right? That you don't put your answer for angle B and angle C spot. I see stuff like that happen more often than you think on students' work. And now we're ready to find angle C. How are we going to find angle C? Good. So 180 minus 34 minus our last answer. So about 90.56. Everybody feel good here? So again, fairly straightforward, right? Nothing super tricky happened. The only thing that we really need to be careful about is when we have that choice of which angle to find first, we pick the smaller of the two angles. So far, so good. But again, this should feel pretty similar to all the other things we've been doing. No big deal. Okay. More better segments here. So let's solve the triangle with side lengths 5, 8, and 10. Now, it's probably not necessary to draw a triangle to decide what situation we're in. It is side, 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 but I'm gonna do it anyway, just because it gives me like something to look at and a place to write down my answers. Everybody okay with the drawing and labeling, right? We've hammered on how we label the triangle a bunch of times. Hopefully nobody screws that up, but like, someone's not up. Things don't work out. First thing you should check is make sure you've drawn and labeled your triangle correctly. If you didn't do that, everything's gonna be a mess. So for a side, side, side situation, I wanna remind you that we go back to 7.1, when we drew our decision tree, we have to check for the number of triangles in a side, side, side case. It could be 1 or it could be 0. The good news here is the check for a side, side, side is massively simpler than the side, side angle check. So the only check we need to do is to make sure that leg plus leg is greater than hypotenuse. If it is, you have one triangle possible. If it's not, there's nothing to do. It's an impossible situation. So the only place that's kind of a concern is how do I know which side is the hypotenuse? It's the biggest one. Not the one listed third, but the biggest one. Will I try to trick you and write them in non-ascending order? I don't know if it's intentional, but it probably will happen at some point. Okay, don't just assume the hypotenuse is the third side listed. You know, be like, no, mystical, like, do not believe the number of students that get thrown by, that kind of thing. So if we check ours, 8 plus 5 greater than 10?
Yeah.
Yes. Okay. Well, I guess we'll write it here. Okay. Now again, just like the side angle side, the order in which we're solving the angles here matters only in as so much as we want to avoid that nasty two triangle possibility. Again, if we follow the directions I'm going to give you, you don't have to think about the side angles or the side angle possibility. If you go in an order that you want to do, you do. Okay? So I'm going to tell the order I'm going to give you makes it impossible for you to land in a side angle situation. That's what I recommend. Simplifies everything immensely to be able to avoid that. Okay. So for a side, side, side situation, you want to find the largest angle first. So if we go back and we look at our triangle, what angle is the largest angle? R, the pirate's favorite angle. Get it? Because R. Oh, it could be the C as well. So it makes it a good joke. Is that one person answers it one way and you're like, oh no, you're wrong, it's this one. Yeah. Alright, fine. Alright, so we're looking for angle R then. So we're going to write our law of cosines. We'll say r squared is equal to p squared plus q squared minus 2pq times, cosine of angle R. Okay? A place to be careful here when trying to solve for angle R, a common algebra mistake I see students make is they tape all of those numbers together into their calculator and make that the coefficient on R, or cosine R. What's the problem with that?
Yeah, PEMDAS is.
Yeah, they're not like terms, right? These three numbers can go together, and these two numbers can go together, but you can't squish them all together because 2, 5, 8 are attached to the variable. 5 squared and 8 squared are not. Does everybody see that?
19.
So we'll just start by moving these guys over. And I'm not going to bother like changing anything in like multiplying or adding or subtracting or squaring anything until the very end. I'm just going to type it in my calculator all in one shot. Less times I type it in my calculator, less chance there is for me to make like some stupid fat-fingered mistake. Now I'm going to divide this coefficient to cosine R over. Very common mistake, again, students drop a negative sign at that step. Should write that in red, huh? That's what I've been doing. Oops-a-daisy. Oops-a-daisy. And then to get angle R all by itself, I gotta get rid of that cosine out front. How do I cancel out that cosine?
Inverse.
Cosine inverse. Again, who's noticed, how do you know at the start of the problem whether you're gonna need to use an inverse or not? Has anybody picked up how you know right away? How do we know? If you're finding an angle, if you're trying to solve for an angle value, you know you're going to need to use the inverse trig function at some point in there. Now that's calculator time. So cosine inverse. Now I got to be real careful here because the fraction, so I'm going to use that horizontal fraction bar. So I get 97.9. Okay. Now we have two angles left, just like we did in the side angle side situation. So just like in the side angle side situation where I have two angles left, I want the smallest of the remaining two angles. So in this case, that's going to be angle P. How do I know angle P was smaller than angle Q? Because P was the smallest side, exactly right. To solve for this angle, I'm going to use the law of sines now, because I have like a side-side angle situation going on. So I'm going to have sine of angle R that I just found over side R equals sine of angle P over side P. Now the proportion, I'm going to cross multiply, divide, and take sine inverse all in the same step. Is everybody okay with that plan? Just condensing some algebraic steps. We've done this type of problem like, I don't know, a dozen or so times. I think I've harped on you guys enough about what's this equation called, what type of equation is called, and how do we solve it, and how do I cancel out this? You know, like we've done this dog and pony show a couple of times now. Let's just streamline this a little bit, Mr. Kulik. So I have 5 times, sine inverse, 5 times sine of the answer to the previous one divided by 10. 29.69. And so for angle Q then, I have 2 of the 3. So I can just subtract from 180. And I get 52.41. How do you guys feel on that?
Can you scroll back up to when you're doing the law of cosine? You didn't make sure you divided by each side because you didn't have the angle, right?
I'm solving for R.
But if you didn't have the angle, we would just go with cos.
We need in the side angle side situation, we have the angle and you're missing the side length. No rearrangement is necessary. Now, Alex points out a good point. Every time we solve a side situation, we have to do like this exact same annoying algebra, right? Let's just do this algebra once using the general law of sines with like a squared, b squared, c squared in it. And just get a new formula that has the angle isolated already for us. And reduce the amount of algebra we have to do on a daily basis. Let's just do it once generally, and then we can use it as an alternate version of the law of cosines. Is everybody okay with that plan? Save us a little bit of hassle later on. So we subtract over the b squared and c squared. Right? We divide over the negative 2bc. Now, if I look at this fraction, I have a bunch of negative signs in it. That's kind of gross. What I'm going to do is I'm just going to push this negative sign from the denominator into the numerator, right? Because 1 over negative 2 is the same thing as negative 1 over positive 2, right? So I'm just going to make this positive and then like flip the signs on everything over there. That gives me just one negative sign railing around instead of like 3, just one less thing to drop. So I'm gonna rewrite this as like b squared plus c squared minus a squared over 2bc. And we'll just do cosine inverse of both sides. So that's like my alternate version of the law of cosines where I'm solving for an angle. I'm only going to write one version of it if everybody's okay with that. Everybody's good?
How did you do the negatives in the B and C?
So I know that like 1 over negative 2 is the same thing as negative 1 over 2, right? So if I have a squared minus b squared minus c squared over negative 2bc, that's equal to the same thing as positive 2bc, negative a squared minus b squared minus c squared.
I'm talking about like on the top.
Yep,
Oh,
and then I distribute the negative through, and I got this. Does that make sense?
Yeah.
So just like algebra is all I did there. Yes.
Why couldn't you just have the BC on the bottom and BC squared on the top side, so it's just B plus C minus A squared over 2?
Because this is b times c, and that's b
Got it.
plus c. Is there like 2 different things? If I had like, like 1 times 2, and I had 2 plus 1,
Yeah.
you can't cancel those out, right? Like, that's crazy talk. Yes, sir.
But the other equations have the same thing with the switched.
Yeah, so the only thing that you have to worry about is that, like, those guys match, right? Whatever the angle you're solving for, that's the side you're subtracting, right? And then where you put the other 2 numbers doesn't really matter which one you call, because they're just the legs and they're interchangeable. So all you have to do is, like, applying this is the angle you're solving for, that's the side that's getting subtracted.
Really?
Yes. Does that feel good, Luco?
Yeah.
And that makes it relatively easy to adapt it to whatever we're calling the letters, whether P, Q, and R, or A, B, and C, or if I'm solving for angle C instead of angle A, like, I just have to make sure that the side being subtracted matches the angle measure that I'm finding, and then fill the other 2 sides just go in the other 2 spots, it doesn't matter which one.
And I also on the bottom, where does he go?
Oh, I think it just, like, I probably brushed it and I just lost it. So yes, thank you. I thought it was there at one point and I probably just like brushed it with my sleeve and it erased it or something. Maybe I forgot it. One way or the other, it should be there.
Okay.
Yeah, it should be there. That's the answer to your question. Where did it go? I don't know, but it should be there. Okay. You feel okay about law of sines, or these law of cosines problems? Again, fairly straightforward in comparison to that side-side angle case. What I want to do now, as our final thing today, is I want to consolidate these flow charts that we've built over the last couple of days into one big flow chart. Okay. So I'm going to start with this guy. Bigger. Okay. So if we don't have a right triangle, and it's angle, side, angle, or angle, angle, side. You just use the law of sines to solve. Order doesn't matter, no special considerations needed, no inverses are needed, like nothing unusual, just regular old. If we have the side angle side situation, I'm actually going to do this, or side angle situation, then we're going to take this guy, go ahead. Ugh. I did too much highlighting here. All right. What was this, right? Was it greater than? Tessa, what was opposite side greater than the other side? Was that what that said originally? I think I lost it when I did the erasing. I know you write everything down, that's why I'm picking on you. And I don't want to go back to my notes and try
It's less than.
It was less than?
Yeah.
Okay. And is that after we made the correction?
Yeah.
Okay. I just wanted to double check because I know you came and asked me the questions like, well, I got all these wrong. I was like, oh boy, Mr. Pruitt did a bad thing. Okay. Oh, it was these guys that was screwed up, right?
Yeah.
It was just that. Okay. All right. Just shrinking down. So we get you all. All right. I remember there was some issue with these notes. I just wanted to make sure I didn't take bad information with me. So take that. Okay. Okay. All right, so we'll do that, marry that to the end. Is everybody good with what I'm doing? Just kind of like consolidating all these flow charts together. we should put. Stick that in there. But that's now consolidated everything into one flow chart. Depending on how comfortable you are with this, that's something you could put on your, try to get onto your half sheet, or just parts of it onto your half sheet, the parts that you need. I don't know how, I mean, like, microscopic your handwriting is enough to get that all onto a half sheet of paper or not, I don't know, but like, some of you, I think, can probably make that work. Some of you, it might be an exercise in really some neatness that you're probably gonna not pass, but that's okay. You just gotta be comfortable enough and you can like segment it. You know what I mean? So just be like, okay, I'm just gonna use this, I have the SSA piece, and then the other pieces, and like that probably, if I do that as two separate pieces, I can probably get the whole tree on there. You know what I'm saying? But I wanted to kind of connect it all together to see how it all, so you guys can see it all fit. The only other thing I would include on my note card, aside from examples, would be that angle version of the law of cosines that we just derived a moment ago. That's probably nice to have. It saves you a little bit of time and algebra sweat on a test. Does everybody feel okay with what we've done today? Consolidation look good? Is that helpful? Seeing it kind of all laid out in one piece? Since there's a bunch of different things that can happen, it's nice to kind of have it in one organized, like, okay, first thing I do is this, and then I check this, and then I check that. And if it's this, I do this, and if it's that, I do that. I think helps really kind of keep it clear in one place. At this point, we've done enough for the homework quiz. The homework quiz would cover these first three sections. I would provide the law of sines or cosines on the homework quiz. You don't have to memorize that. Should be prepared for that at some point this week. Just giving you a heads up. Yeah, there's not a lot of days, class days left this week, so you process of elimination that guy out. We'll also do 7-4 when we take the homework quiz, and then we'll be looking at review day and test the following two class periods. Just giving you a preview of what's to come. 7-4 is super easy. It's just like, just doing formulas again. So we're just doing area this time instead of solving for side lengths, we're just solving for areas. Not a big deal. What do you guys think? Does this feel all right? Okay. So we're looking at test day sometime next week. End of next week, probably. We'll do 7-4 this week, we'll do the review day, and then a test the following week. Okie dokes. And then we're leaving sine, cosine, and tangent bonds, and going to back to like other types of functions that'll class will feel more similar to like an Algebra 2 class in that regard. So the geometry aspects fade away. It becomes more algebraic. Depending on who you are, maybe like, or, oh, but that's the plan. Cool? Any questions for me? At this point, homework-wise, you can now do I screwed that all up. Did it more than once. Okay. You can now do 15 to 22. So 15 to 22 is just solve the triangle. and they're all mixed up. All the 5 different possible starting conditions are all mixed up in there. So you have angle, angle, side, you have angle, side, angle, you have side, angle, side, you have side, 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 you have side, side, angle, all mixed up in there. They're all together. That's gonna be what it's will be like on the test. I won't tell you which case you're in. I'm just gonna give you the starting information, ask you to solve the triangle. Everybody's good? So that would be part of Sunday's homework as well as the 5 through 14 that we assigned last time. So for Sunday, you're gonna be looking at 5 through 22. Some of us, I think, still haven't done the 1, or turned in the 1 through 4. Again, I checked those on Sunday, entered in zeros and missings if it wasn't in your notebook where it was supposed to be. If you think like, ooh, I had that turned in, I got marked missing. Double check 1, did you put it in last semester's notebook? Because people have done that several times in several different classes already on me. Double check that it's in the right spot. And then 2, that you've got your notebooks in, you know? And if those 2, after you've done those 2 things, talk to me and ask me if I can still see it. If I can, I'll mark it in, and if I can't, well, you probably wanna come in and just show me and I'll figure out what the heck is going on if you're unnoticed, why it's displaying on your end and not mine. Okey dokes. I'm done talking. You guys are free to get cracking on your homework. So if you got a solid 30 minutes here to pump that out, you get a big chunk of it done. That's it for me. Cool.
I just-
Yes, sir.